When I was asked by Teachers TV to present a masterclass in maths, I chose to teach a lesson about averages. My students are Year 9s from 2 North London schools.
4, 5, 6, 7, 8, 9, 10.
So 11 is there, 12's here, and 10's here. Right, OK. So the 10th jar is a 31. OK. 31. The 11th jar is a 32. So the median is 31.5. That's brilliant. OK, I'll put them back in there. Have I mixed them up? Have I got it right? Yep. So what's the median again? 31.5. Quite close to the mode. Not bad. All right, then. What other average do we need to work out? The mean. OK, work that out quickly, then. Oh, you can't see the jars, can you? There's a 27, 20, 27, 29. Got that? Added that up? Yep. 30, 30. There's 5 of those. 13, 30, and 30. And a 31, don't forget that. 3 32s. How many 33s?
3.
3. Have you got it so far? Have you added it up? Yeah, keep it in your head. 34, 35. What have we got? Oh, 2 36s. Add them up. Yep. What have we got? It's a bit too much, isn't it?
Yeah.
What could we use to organise this data more effectively? Yeah? A frequency chart. You mean a bit like this one I've prepared over here?
Yeah.
Ah. Number of jellies, frequency. Brilliant. OK, we'll put them into a frequency chart. Now, if you look in your clipboards, you might find a chart that looks exactly like this. Or very similar to it. OK. We've got a first column where it says number of jellies and frequency. And what we're going to do is organise our data much better. Akil, read out for us exactly what we've got. Now, we'll start with the 27. So if you shout out 27.
27.
And shout out the frequency.
2.
2. We all got that? Have we all found a chart? Yeah. So we write 27, 2. Brilliant. And then we'll just whiz through these next few numbers. So go for it, Akil.
29, 1.
29, 1.
35.
35, yep.
31, 1.
31 is 1.
32, 3.
32 is 3. Yep.
33, 3.
33 is 3.
34, 1.
Yep.
35, 1.
35 is 1.
And 36, 3.
36, 3. Have you got all those, guys? Yep. How does this help us work out the mean? What do you think? Esther?
You times the number of jellies
times
the frequency, then you get a total and you divide it by 20.
Ah, so you times the number of jellies by the frequency. Can I stop you there, yeah? And what, you put it over here? Why would you do that?
So it's basically like you adding up all of the frequencies.
But in a quick way. Brilliant. So if we call this third column the number of jellies multiplied by the frequency, if you want to just add that in as a column heading, OK? The number of jellies times the frequency in each case. So Esther's explained that extremely well. OK? What did you say the 54 represented?
The number of jellies.
The number of jellies in these 2 jars here. Brilliant. So that's 27 and 27, obviously, is 54. We've got 129 and so on. So what we're going to do is now work out the total of this column, and that will give us a total number of sweets overall. Well done, Vista. Brilliant. 29, 150. I tell you what, would you mind filling in these, yeah? Because you haven't got a clipboard, have you? Could you carry on doing those? Are you left or right-handed? You're right-handed. If you stand to this side, and then we can all see what you're doing. Yeah. Can you do it in your head? OK. Interesting. 30 times 150. There's up, 636. Have a look. 32 times, hang on a minute. Oh. 32, that's a 3.
Is it?
You've misread it over a 5, haven't you?
Yeah.
Oh, that might get you the right answer now. It's looking good.
636.
636 divided by 2, 3, 4, 5, 6, 7, 8, 9 different numbers there. 636 divided by 9. What did we get?
You need to divide it by 20 to get the mean.
Of course, we have to divide by the total number of jars, don't we?
Yep.
Divided by 20. 636 divided by 20 equals?
31.8.
Oh, right, write that up there now then, like, me to put the mean. Yeah, that's good. 31.8. So, we can put average contents per jar is 31.8 sweets. Yep.
No.
So that means, like, you hopefully get 31 sweets, and if you're lucky, you'll get a bit that's had a bite taken out of it. 31.8 is a silly number, isn't it? Round it up? Yeah? To 32. Scrub 31.8 out. We'll put 32. That's pretty good, actually, because that's sort of round about where the numbers are, isn't it? Yeah, remember they're going from sort of... We've got a lot in the 30s, haven't we? Early 30s.
And it agrees with all the other things. Divided by 20 to get the mean. Or averages.
Come up here. I love what you said. It agrees with all the other averages. Come over here. Do you want to just carry on? You take the rest of this lesson. You're brilliant. Carry on. Over to you. It agrees.
So it agrees with the mode and the median because they're very close. They've literally two difference in the mode and the mean, and as well as from the median, you can actually round up the median to 32, and it would be the same.
Absolutely superb. Give him a round of applause. Thank you very much. You are good. Well done. Sit back down for a minute. I think this is really hard work. We've worked so well. We've done so well. I think we all need to have a little sleep, don't you?
Yeah.
A little rest. So I want you to put your clipboards down because it's night time and we're all going to sleep. Oh, wake up, guys. Oh, my goodness me! My jars! Someone's knocked it over. One of my jars. Kishan, come here. I think someone's been stealing my jars. Can you just count them up quickly? I'm in a real panic. Just count them up.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
There's still 20 jars, thank goodness for that. Do you notice anything different about these jars? Look at these ones. Where have the labels gone? How many are without labels?
4.
4? What's happened to them?
They've got 2 sweets in them.
They've got 2 sweets in each. Do you think these have been messed about with?
No.
How do you know? What if they've mucked all the labels around too? Everybody, come and grab a jar. It doesn't have to obviously be the same one as you had. Grab any jar and recount the sweets in all the jars. I can't believe it. The evidence suggests that if it's still got a sticker on, it's still got the right number in. It looks like it's just these 4 jars, isn't it? Yeah. That have been messed with. Come back up to the belt and put them in the right places. Thank you. Oh, look at these. If you've got a 2 jar, just stick it over here. Yeah. Okay. We've got enough room. Lovely. Rena, can you just stop up here a minute? Just come round the side. So we've got Rena here helping us. What I'd like to do is redo the problem with the new numbers. Go for it. So 2
4.
is 4. Okay, so we'll just go through these. Okay, go for it.
27 2.
27, 2, yep.
29 1.
29, 1.
31.
31.
31 1.
31, 1.
32 3.
Yep.
33 3. 34 1. 35 1.
35, 1.
And 36 3.
36, 3. We've worked out what's happened. Samuel sussed it out. 4 of the 30s have gone. And if someone came in now, the inspector, and saw the range, what would they say to me? What would they say? With a range like this, it's going from what, 2 to 36. What is the range?
34.
I'm just going to make a note of that. You carry on working out the mean. Since the break-in. Do you know what? The range is strange. So let's come up with some figures. Okay. Excellent. Are we getting values for the new mean? Yeah. Okay. Would it have gone up or would it have gone down?
Down.
Why would it have gone down?
Because there's less 30.
There's less sweets.
Less sweets.
Okay. So there must be a reduced mean. What do we get? 26. So if you just write the mean, 524 divided by 20, that's what we're all agreeing with. Okay, and Emil's writing it on here, 26. Do the 0.2. Do the 0.2, I think. 26.2, thanks. And then it was your idea to round that down, wasn't it? Yeah. So we'll go for the mean of 26. Okay, oh dear. Thanks a lot if you want to sit down. Thanks very much if you want to sit down. Okay, brilliant. So we've got a mean of 26, a really big range. This is not good. This is not good at all. Even the mode's changed. Look at the mode. What's the mode now? 2. It's really mucked us up, hasn't it? So, it's just like the problem we had when I introduced Johnny's Jellies at the beginning. When we had the 10 companies, we decided the mean and the median were good numbers to use, £5.50. When we had that extreme value, okay, we decided the median was a good one to use, didn't we? And the median was £6, wasn't it? With a problem like this, we've got similar extreme values. This time, the very small values, aren't they? What could we do to these values? Yep.
We could put them all in one jar.
We could put them all in one jar. I could even...
Eat them.
Say that again? Say that again?
Take them away.
We could take them away. We don't need them. If we can keep our range low, we're not going to lose our dough. So, have we all had a good time looking at averages? Yay! What averages have we got? We've got the mean. What's the mean? We add up the...
Number.
And divide by...
How many numbers there are?
Good. What's the median? We put them in order. Find the middle number. What's the mode?
Most frequent.
Most frequent. What's the range?
Highest to great lowest.
Beware, though. What happens when the range is strange, if it's big? What might be around then? Outliers. Who said that? A good word. Outliers. Was it you?
It was all of us.
It was one of you. Okay, an outlier is a posh name for an extreme value, yeah? Okay, very good. So if we've got a large range, beware of those extreme values. Remember, one thing from me today. If your average is good, then your numbers can be understood. Give yourselves a round of applause. Well done.